Students, today we will learn about wave velocity, group velocity, and the relation between the two. Now, if you have a single wave passing through a medium, the velocity of its propagation is known as wave velocity or phase velocity. For instance, if we have a wave whose equation is represented as y is equal to a sine omega t minus kx, where a is the amplitude of the wave, omega is the frequency, k is the wave vector, x is the displacement, and t is the time. Now, the velocity of the wave is given by v is equal to omega by k, because we know that omega is 2 pi nu and k is the wave vector equivalent to 2 pi by lambda. So we are left with nu lambda only, and we know that is the wave velocity or phase velocity. Wave velocity or phase velocity. Now, if there are more than one waves, a group of waves passing through a medium, then the velocity of the group of waves is called as group velocity. So group velocity is the velocity of the wave group. For the purpose of evaluation derivation, let us choose at least a group of two waves. So let this be the first wave represented by y1, and y2 will be the second wave, which will be written as a sine omega plus d omega t plus minus k plus dk into x. That means the second wave is differing only very slightly from the first wave in terms of frequency and wavelength. Now, from the superposition principle, we know that the resultant displacement will be y is equal to y1 plus y2. So let us add them up. So y is a, for this will be two sine factors, sine of this and sine of this. So we'll write them together. Sine of omega t minus kx, because we know that a is a common factor here and here, plus sine of omega plus d omega t minus k plus dk x. You can choose to write a curly bracket of this type. Now, you are aware that this formula is equal to sine A plus sine B, and we know that sine A plus sine B is equal to twice sine A plus B by 2 into cos A minus B by 2. Now let us apply the same. So y is equal to A. This twice factor will also carry out, right? Internally, what can we write? Sine of A plus B. So omega plus d omega. So that is 2 omega plus d omega, and then this factor of divided by 2 and t minus k plus dk, that means 2k plus dk, then this 2 of the formula, x, into another factor, that is cos of a minus b by 2. What is a minus b? Omega minus d omega. So that will be cos of d omega by 2 t minus dk by 2x. Right? Now, we understand that we can easily simplify it. This 2 will go with this. We are left with sine of omega plus d omega by 2 t minus k plus dk by 2 into x. and the other factor will remain the same, that is cos of d omega by 2 t minus dk by 2 into x. Of course, we need to put all this in common braces because this entire thing forms the argument of cos. Now, we understand that d omega and dk are very small quantities. Therefore, d omega by 2 and dk by 2 can be neglected. So, we can choose to write it as y is equal to 2a sine omega t minus kx into cos of d omega by 2 t minus dk by 2 x, right? Now if you look at the resulting equation, this is the original factor, the original single wave whose frequency is omega, whose wave vector is k, but then we also get a factor which is variational both in t and x. So this cos factor is modulating the original factor and represents a group of waves whose velocity will be given by, obviously, the group velocity will be given by d omega by dk. So d omega, in fact it is d omega by 2 by dk by 2. So you understand it's d omega by dk. Now, let us choose to write it as, so on the next page I can write it for you. We know this k is 2 pi by lambda, right? So for dk, I'll write it is minus 2 pi by lambda square. That means this group velocity is d omega by dk, and that is d by, for dk we can write d omega. For this dk we can choose to write it as d of 2 pi by lambda, because we know that k is 2 pi by lambda, and that is originally we have found it that it is equal to minus lambda square by 2 pi d omega by d lambda, right? Next, now this Vg is, let me write it again, it is minus lambda square by 2 pi, internally we have d omega by d lambda. Again for this, it's quite easy to carry it forth from there. So it is d by d lambda of omega is 2 pi nu, right? So that is minus lambda square, I hope you understand that it goes like this, minus v by lambda square plus 1 by lambda dv by d lambda, where for this nu I have chosen to write it as v by lambda. Nu I have chosen at v by lambda and then differentiated one term and then another term. This 2 pi cancels with this. So what do we get? We get that this group velocity is this and this goes, this and this is plus wave velocity minus lambda times dv by d lambda. So this is the resulting equation. Obviously, from the wave velocity, from the phase velocity, we have to subtract a factor to give the group velocity. That means group velocity is less than wave velocity or phase velocity. This is the case of normal dispersion. However, there are certain cases where this is not true. We will try to know about them a little later. In case of electromagnetic waves, we have anomalous dispersion where this factor is greater than this. We'll come to that a little later. So we are done for today.